So welcome you again on this part of the AGS master course, and this part we will learn how to find target home, to find your solution to your target, which means basically the elevation and the azimuth. You see, as we discussed, we are expecting some enemy activity there, and how to find out what enemy activity is. It is that we just fly there with our drone, but without drone I'm taking an area cameras here somewhere in this crossroad, and with that area camera we can observe. Yeah, that is it. You see, that is the bar. We are over there, over here in this clearing in the middle of the forest, and we're looking at there. This is the barn we are expecting enemy activity, and here you have, next to the barn on the left side, you have an enemy encampment where we will engage. Okay, so let's go to the map, and here is the enemy activity, and you see, well, on the southern edge of the forest on your on its left, we found the target. Okay, what we need, obviously, the distance and the azimuth to the target. We don't really have to hustle much about the azimuth, because if we rotate our map tool, our plotter, onto the target, we will just be able to read the site azimuth counterclockwise on the bottom scale, 39.58, 39.58. 39.58. So bring up the site, and 39.58, and we rotate it onto it, and now our barrel should be aligned with our target. Now what we need is obviously distance. Well, it's not that far, so you might not want to use this big scale which measures for 5 kilometers. The grid scale is just fair enough to measure 1, 2, 3 kilometers, because it's more accurate. So from my position, I'm going to the target. You see, that's 1000 meters, and one of these sections is 20 meters, so that would be 1000, and that's 10, 15,000 and 15 meters. So the target distance is 1015 meters. Okay, but we don't only have, unfortunately, distance, we also have elevation difference, because it is, you see, if I bring my cursor onto it, it says that it's 160 meters elevation, and I'm at 181. So I have an elevation difference of minus 21 meters. Yeah, good. So let's find our solution for that. That is our range table. The problem is that I don't have elevation difference, but let me just show you how to work around that. So our target distance was 1015 meters. So our base elevation will be corresponding to 1000 meters, which is 1170. The next elevation for 1050 meters is 1149. So in between 1000 and 1050 meters, how much elevation change you need? It's 1170 minus 1149, and that would be 21 mils. So basically 21 mils of elevation change will give you 50 meters of range change. So what we need to know is 1 mil, how much range change 1 mil gives you, and that is pretty much 50 by 21, and that gives you 2.38 meters. So 1 mil gives you 2.38 meters. Let's put that down. 1 mil gives you 2.38 meters of range change on that. Well, the azimuth change is easy because the 1 mil of azimuth change 1,000 meter gives about 1 meter, but anyway, we don't need that yet. I misspelled. Doesn't matter. 2.38 meters. So, what else we need? Because of, so our base elevation was 1170, but we want to shoot for, our base elevation for 1000 meters was 1170, but we want to shoot for 1015 meters. It's not really, because we have elevation difference, so we have to make some range correction for our elevation difference. But how much? Let me just show you, because you don't have on the range table correction for the elevation difference. You can still plot out pretty easily what you want to do here. What you need it is to understand your impact angle. You must understand that the impact angle of your projectile will probably close to equal of your launching angle, so your shooting angle. And in our case, it will be around 1170 mils. And if you see that this is our 0 mil, and if you elevate our gun like 200, 400, whatever, this is 1170 is here. So your projectile will arrive to its target about at that angle. Why is it important? Because without going into any deep trigonometry, this is a tangent. So if your aiming point was here, your 0 level aiming point, but your actual aiming point is down here, you see? You understand that at 1170, that will be the path of your projectile. So the range, what you need to correct for, is about 1/3. If you see it, 1 square, 2 square, 3 square, it's only 1 square a little bit. So the range what you have to correct for is about 1/3 of the elevation difference at that impact angle. And it is pretty easy. You can plot out anything, but you see at 45 degrees it just equals, which is not a surprise. And if you go a lower elevation like 400 mils, it will be pretty much different, because for the elevation difference you need to multiply by 3 times the range difference. But at 1175 it is about 1/3. So if we have 21 meters of elevation difference, what we have to compensate for is 7 meters, and it is lower, we have to aim 7 meters shorter. I hope you understand that why we need to aim 7 meters shorter. So that means it's not really 10, 15 our aiming point, but 7 meters shorter. It is 10.08. And we just calculated that 1 mil gives us 2.38 meters. So what we need to do, we need to aim 8 meters further than 1000 meters. So we divide 8 by 2.38, and we get that it's 3.36 mils. As we need to add 8 meters to our range, that means we need to depress 3 mils our gun from our base elevation, which was 1170, and that is 1167. That's how you calculate your solution, 1167. You bring up your sight, set 1167, 7, 8, 9, 10, 11, 20, 67, it's 1167, and just elevate until the horizontal bubble is in the middle. That's it. You see, this starts to move up and down. It is in the middle. You go again to your aiming periscope and align it with your aiming circle, aiming periscope with your aiming pole, and that's just fine. You should be at your target now. Now that we have our solution, you must understand before firing your AGS that it is an area weapon. So it is inherently not that accurate. It can be anywhere. We can be anywhere around 50 by 50 meters radius of our target. So what we need to do here is to spread our shots. But how much? Well, it's a 50 by 50 meters thing would not be a bad thing to think about that. But how do you do that? Well, you have a mill scale. That's why you have a mill scale here, and it's sideways. It is 20 and 40 mils. So at 1,000 meters, if you want to be in a 50 by 50 meters radius, well, you might go off 25 mils here and 25 mils here, you see, and that is gives you 50 mils, which 1,000 meters will be 50 meters, you see, 25 meters here. And horizontally, how do you get to 50 by 50 meters square? It is that 1 mil gives you 2.30 something meters, 2.30 something meters range change at that elevation. So what you need to do is, again, you need to change how much. It is 20 mils, so you need to give 10 mils here and 10 mils here. So what you need to know is to imagine a 25 by 10 mils square here, and just spread out your shots into that. Okay, let me show you how. So again, we find the middle of it. We find just the middle of it, and you see that is 25 and that is 25 like this, and that must be around 10 like this, and that must be the bottom of the red part is 10 like this. And let's just start. And see what we did. And see, here is the encampment. Yeah, that is kind of short, but yeah, that's the next shots. We'll just get into it. You see how I just covered the area, and it is pretty effective, but I was aiming a little short. Anyway, that's an area weapon, and that's how it is supposed to work. Well, I hope you enjoyed it, and have a wonderful day mastering your AGS 30. Bye.